And I'm out that fast. How you doing, Roy?
I was going to say, is that the end of the show already?
Boom. Yeah, I'm out. How you doing, buddy?
I'm not bad. I'm not bad. It's a sunny day. Again.
Yeah, it's not bad. So check it out. Things look a little different across the bottom. Let's get two of you like this, maybe.
That's a bit better.
So this morning I was taking a look at the front overlay because we seem to, find a problem with it. And I ultimately got to a point where I was like, oh, if I comment out these lines of code, I get 30% of my GPU back.
What?
Something
what possible
like that.
lines of code can do that?
Yeah, well, it didn't make much sense, but I'll show them to you here. Let's jump in here. You can kind of see the nameplates are looking a little bit different. I'm already
They are.
Yeah.
You can see the text, but no background.
Yeah, so let's do this. Let's do it. Here's the normal code right now. Let's bring this up. We're already at 99%, 100% because we're streaming now. But the deal is it's in here. This is the problem space right in here. If I take, essentially I think my theory is it's this line of code, this line of code, this line of code, and that line of code.
Okay.
Is what I think it is.
So doing things to nameplates. Bad.
Yeah, drawing the nameplate. So let's save this. Let's refresh here. So I'll click right here to refresh the cache. Let's bring up this, see if we get any relief at all on here. With the refresh, no nameplates are being drawn, so we might be able to get a little bit of relief. Not really. We can see it's 44%, 43%, about in that space right there. So yeah, we can't really test now. The problem is we can't test because OBS is taking up GPU just to do the live streaming. But the problem was essentially in this try finally block. If I commented it out, then things would work okay. Let me initialize the player data. And we should see really very little change here. It should be about a 42% on that. It even dropped down for a minute. There it's back up at 42, 43, down to, 41. So 40%. So not a lot of change there. Okay, let's take those 4 lines, uncomment them out, and I bet you we can still see that one process go up. So back over here, refresh that cache, come back to the task manager. This one that's selected is the one that we're watching right here. So let's let it
4550. Yeah.
I want it to settle down for a second because I don't have the nameplates showing yet. Okay, now let's initialize the player data. What's it at? About 42%. I bet it jumps to 60. Well, I don't know. Oh, look at that.
There you go. Jump to 60. A little bit down, but hovering 50 to 60.
See what's happening? It's like that's 20. What is that? It went from 40 to 60% of the GPU. So it's taken up 20% of the GPU to draw the name tags. I'm like, what? This code is not much different from code that's throwing sprites all over the place.
Yeah.
Right? I don't get it. I don't get it at all. I was like,
okay, is there any difficulty because it's drawing them over the top of a constantly changing set of graphic, i.e. the coins?
No.
If you were to move the nameplates to a different graphical location, would it still be as intense?
No, that doesn't make sense to me. I'm not even going to try it. I'm sorry, Roy. I'm like, no, that should have zero impact.
If
that's the problem,
kind of crazy because even if that was the case, it's not like nobody else does that, right? Intense games are doing that kind of thing all the time, and that shouldn't be a problem.
Mm-hmm.
Okay, but you're saying, specifically the nameplates.
Yeah, I don't get it. The only I'm trying to work it out in my head, and what if I'm trying to come up with a scenario where this was called 1,000 times? Then I'm like, okay. So I'm looking through the code, and who calls this? Well, it's called in a for loop up to the number of players. But I looked at players, and it just seems highly unlikely that players is going to get giant, because it's contributed basically an initialized player data where we're passing the JSON parse, which itself has limitations on the size of the JSON that can come across. So there's no real way this is going to get, by some error, get to be a massive amount of players. And here, every time we call initialize player data, we reset it to empty, and then we do a for each and push the new character on there, passing it in. We're essentially cloning the character from the JSON DTO. So that doesn't make sense. We're calling it. Let's see. If the player ID is equal to active player ID, then we just save some fields and we continue. Otherwise, we show the nameplate. And the whole purpose of this is so we draw the nameplate on the active player on top. So the active player is going to get priority there. It's basically those lines of code. Now, what I can do, let's see, what are we doing now? So now we're in the slow mode, right? Where these things are taken, there it is right there, 60% taken. So theoretically, if I rewrite this bit of code here to not use, and by the way, I really suspect it's this one right here is the biggest, draw cropped by index, because it's cropping, whereas the others are not. So let's just try this. Let's comment this line of code out. Start up some music here so we can be entertained while we're not talking. And what do we got here? We're about 60%. Okay, we're 60%. Let's refresh. We should see a drop immediately because we're not drawing the name tags anymore. See?
We do.
Okay. Now I'm going to initialize player data to get the name tags back. And let's see, is it going to go all the way up to 60 or will it be noticeably lower? I just hit initialize player data. We're drawing the name tag text.
It is up, but it's not up as high.
Yeah. It's, well, wait, there it went to about 57.
But before I'd argue it was 57 through 61. Now it's more like 55 through. Okay, it did tip at 60 just there, but not generally that high.
Kind of interesting. Okay, so let's comment out the other 4 lines of code, right? Because it's not the math that's killing the GPU. I'll tell you that much.
Really shouldn't be, should it?
Yeah, I am not getting this at all. And I'm looking at this, right? So the base animation, draw by index. Here, let me show you that code. I'm pretty sure that's pretty fast. We've been calling this all over the place. It could be that there's scaling. I'm not sure. But if there's scaling in it, that could maybe slow it down. But this code is being used by the engine. It's called millions of times a show, probably. Right? This thing is all over the place. So the likelihood that there's a problem with just the name tags here does not make sense in this code. Hey, Codebase Alpha.
Hey, Codebase Alpha.
All right, so I'm going to just comment out these other ones here, and we'll see if we now noticeably will drop it down. So let's see where it's hovering at about. 57? Seems like about 57 there. It goes up and down, but I'm going to throw it around that space. I don't know. It's wavering a lot. It's hard to tell for sure. Let's do a refresh. There's the refresh. Should see it drop down to about 40 again. Okay. Here comes initialize player data. Did I click the button? Did I do it? Yeah, it looks like I did it. So now only text is coming out. Okay, look at that, Rory.
That's definitely a lot lower.
It's crazy to me. The others are, these other calls, it makes no sense how draw by index should take so long.
We've narrowed it down to these 3 or 4 calls for, shall we say, a decent chunk of our GPU going missing. Okay, so something within these are all draw by index and draw cropped by index, right? they must be doing something non-mathematical, because basic maths is CPU. Okay, they must be doing some drawing that is different somehow to the other drawing. It must be more intense, more repeated, or maybe there are simply operations we're doing under these circumstances that we wouldn't normally do. So I'm thinking canvas or context-related specific stuff.
Yeah,
so
if we were transforming
got to transform there.
I'm not sure we are. We're cropping, but I don't think we're transforming or scaling. I need to double check the code, but I don't think there's any scaling going on here. Let's just look at this. I think scaling is in a scaling is in a. If I'm scaling, I've got to pass in parameters to scale it. So I'm not passing any parameters in to scale it. See the frame index is the last. It looks like chat.
I can see that there, but the chat's slightly. We scroll down a bit, maybe the IntelliSense will be in a better position.
Hold on, let me get it back here. All right.
Oh, that works too. Yeah.
Okay. So take a look here. Frame index is the last parameter I'm passing in. Scale, these other parameters are not passed in. Scaling, rotational, flipping, horizontally and vertically.
So they've all got default values effectively for the internal code.
Right, which means if the code is correct, nothing's happening. There's going to be no scaling. There's not going to be, what happens is transforming is set up here to see if we're scaling, right? This is just flat out math. This is going to happen in an instant, right? So if transforming, then we do a context save, context translate. Then if we're rotating, we rotate it. And if we're scaling, we go in here. But none of this code is going to be executed.
Certainly is in the house.
Welcome, Surly.
What'd you say?
Welcome, Surly.
What'd you say, Karen Manchikati?
I said, don't give me a dirty look.
I just wanted to make sure you knew what you were doing. So, so basically, this code, none of this code, which
Shouldn't
could potentially, should be executed, and potentially this is code that could maybe tax the GPU. So now we're down to here, context.drawImage, get jiggle. Well, get jiggle. If we come in here, it's going to come back and say the amount is going to be 0. She's coming in, kids. Honey, how to do a show? I am in love with that girl, though. I will say that. I know that may be a violation of Twitch terms of service to profess your love for someone on the show live. Don't honey me. Yeah, it's Love Musk. Oh, look at this. Here comes Jetson.
Everybody's coming in.
Get out of here, Jetson. Whoa. Nice flying, buddy. Likes to fly low and slow. It's Jetson. Why'd you say, ooh, sex positive? You can actually tell me here you're in the same room.
Previous Surly Dev.
Oh, Love Musk. She said love. Yeah, she said dude, Love Musk. You figured that out, Rory?
Yeah.
Yeah.
Yeah, you know why? Because Rory's a good listener.
Yeah, Surly said that looked like Mark was checking the house to make sure I wasn't really into house. Yeah, it looked like it a little bit, didn't it? How you doing, baby? You good?
I'm perfect.
In every way?
In every way.
That's the minimum requirement.
For what?
To be hanging out with me. Look at this guy. You want some of this? You got it. Whoops, sorry, I didn't mean to poke your eye out.
Wow, your game is smooth.
It's a smooth game.
You're a smooth operator.
That's right. You've got to be perfect in every way if you want to hang out with me. No, don't. Not on the show. Not live on the show. Thank you. Yeah.
Well, you make it sound like I can pick your nose when it's not live on the show. Like you let me do it ever.
All right.
She makes a good point.
Roy's like, she makes a good point. I'm going to write some code. Are you okay with that? What should I do with this method?
Refactor it.
Okay.
I've been telling you that all day.
Fine.
It's messy.
So,
that code is messy.
Yeah, get jiggle comes back with nothing. I'm not doing any jiggling here, right? Jiggle X and jiggle Y are both set to are 0 for this, so it's not going to be bumping around or anything like that. Yeah, it's just, and then transforming, and this will not be executed. It makes no sense to me. It just makes no sense to me. Or the other option is it's running at an incredibly high frame rate.
Yeah.
Right? So,
Mhm.
and I'm like, wait, how is that possible? Maybe that's what's happening here is that it's not simply the problem is that these guys are, it's not the theory that they're being called, thousands of times. It's that they're being called thousands of times per second because for some reason the frame rate is jumping up in a way that we can't control. But if that's the case, why is the front clock not causing the problem? In other words, if you look at all the drawing that's going on here, let's do this. Let's go get up here to the show nameplate call and go to the show nameplates, right? That's in the middle of all of these effects that are going on here, including the time plus any effects on the time clock.
So the logic is that if it's causing problems because of that, then they should all be causing problems, and we should be able to retrieve so much GPU from this that we actually go, way positive. You should actually have that 10,000% GPU availability,
right?
And you clearly don't.
Yeah. So watch this. I'm at 43. Watch the hit that's going to happen here when we refresh. I've just uncommented those lines of code out. Here comes the refresh. So this should go back. It should settle down. There should be more stuff because of the clock that's updating. But now watch what happens after I initialize player data. It's going to go way up to 60. It'll bump up to 60. And I think it would go higher than that, but it's capped out by what OBS is trying to do. So there it is hovering up at around 60. Now watch this though. I can turn off the nameplates. If I control click the nameplates, all of them but one will go off, and then I can turn even that one off. And now we'll look at our GPU. Our GPU for that entry, see, look, it just dropped down. It dropped down below. So now we're at 40-something%. Right?
So we are, the evidence is mounting. It's in there. Whilst at the same time, the evidence is saying, but it can't be.
Yeah, that's kind of what I'm feeling. Now, let's just play with something here for a second. Let's drop some coins, or let's do a blood splurt effect. All right? Because you're going to see something, right? But the damage, oops, hold on. Let's say 5 damage. Like that. There we go. Everybody hits 5 damage. You should see, let's do 15. Everybody gets 15. Let's watch it when I hit that. You should see something happening there to it. It's not much.
Yeah, it went up a little and then it's down again.
And that's doing a lot more drawing than the nameplates are.
Yeah.
Yeah, there can't be a problem with that code as a classic. There usually is, but it's hard to find. Yeah, no, I agree with you, Codebase Alpha. In my experience, the problem is close to it. It's close, right? If I comment out the lines, it's not happening, but where is it? What's the problem? And so we need more data.
So what about if we challenge our assumptions? I know this is a stupid thing to do.
No, I love this. This is the best idea. Situation like this.
You've got a method in which we are very confident. No scaling, no transformation or anything else is happening.
Can you hold that thought for just 1 second, Rory? Because I want to interrupt you with... this morning I woke up and I'm like, the front door is open. And I'm like, what? Somebody break into our house last night? Why? And the front door is open? I don't even get this. And I go to I realized later, oh wait, I got a security camera on that. Let's see what's going on. It's Karen. She gets it up at like 5:30 in the morning, opens up the door to let the cat out. She's like kind of dazed and she just kind of half throws the door closed, but it doesn't close and walks away from it. I had to share that.
Fair enough.
I wish she was here to hear me share that because, it's so much fun. Anyway, Roy, can we challenge our assumptions? What did you got for me, buddy?
It's kind of a dumb idea, but we're saying that at the moment, if we call this method, when we're calling these 2 or 3 methods, in fact, we are not doing any kind of transforming, any kind of scaling. So if we comment out that code, we should see no effect, right?
The code that scales, you mean?
So we leave the calls in, but inside the method, we turn off the scaling. We literally comment out the scaling. So even if it was trying to scale, it couldn't possibly run that. And is it still high?
Yeah. I can't show you the video, certainly, because she's not entirely, dressed for prime time. So we can't do that. So I hear your suggestion. We can do that. The problem is that will devastate everything. There might be scaling going on that no longer works. Because of that. So we can do that as a quick test, which I'm okay doing. That was over in part is where that was. Whoops, not there. I wanted to go to here and basically come in and say, all of this goes out all the way to there and all the way to there. That's your suggestion. Do we
Kind of,
agree?
yeah. Because what we're saying is that we've got a roughly 60% GPU when we leave the calls to this in. So we leave the calls in, but we make a guarantee now that the calls are not. Actually, arguably, because of what you're saying, we should now see a drop in CPU quite substantially because nothing's scaling.
Okay. I don't think there's a lot of things scaling right now. I don't. I could be wrong. The coins could be scaling or something like that. But we are only going to be refreshing the front overlay, which I'm going to do right now.
I have
All kinds of explosions are happening. Interesting. Fred's on this one. Fred does not need to be here. I'm going to take out Fred right there. Okay. That's not what we want to see. Okay, so I've refreshed it. Let's initialize player data. Did I keep those other lines in though? Let's see if I did. I think I did. Initialize player data. There they are. And oops, forgot to look over here.
So that basically says you're absolutely right in that we're not executing that code.
Yeah.
Which is good because it proves that we must be executing that. Is there anything else we could take out experimentally and without destroying the known universe?
I think we got to look. It's nearby. I think we got to look at how many times we're
There's some
calling
kind
it.
of an error state at the top there being checked for.
Yeah, but it's
Console error. Are we seeing any of those happen?
I don't know. We can take a look at it. To take a look at that, though, we got to shut some things down, which I'm happy to do. Since we're in it and looking at it, let's do it. I'm going to start shutting things down. We're going to lose control of Fred and some other things like that. It's kind of like shutting down the.
I feel like we're chasing around in a literal sense after a bug, with a big mallet, and we're just going to leave holes in all the walls as we try desperately to find this bug. So we've got to be a little careful we don't destroy the known universe in our attempts.
I agree 100% on that. Hold on a second. I need to wait for just the right time to shut down. There it is right there. I want to make sure I don't destroy, I don't shut down while we're saving a file. Okay, I've shut those two pieces down. Now I can come in here and say start. Let's make sure though that the front game has got the lines of code we want in there. Inside show nameplate. Yeah, and we need some, like right now I don't have any code to calculate the frame rate, but I feel like I'm going to need that. By the way,
definitely a valid thing to do.
It was really interesting that everything was cool when I was putting the text out, because I was thinking, oh, maybe it's a font because I'm asking for this non-standard font like every time, but it wasn't the font. It was absolutely not the font. It really kind of boils down to this try and that finally right there, which also, and the try finally should be incredibly fast. There should be no problems there, right? The other thing I wanted to try though, Rory, is to extract this to its own method, but then create an alternate method that takes the same parameters, and in the alternate method, just draw a rectangle.
Yeah.
Right behind it in the right size. Because basically what this is doing is this is actually kind of building a pretty cool thing. There's some cleverness here. Let me bring up a Explorer window and I'll show you what it's doing. It's kind of clever, but it's not really obvious to see. It's not really obvious what's happening here. Let's go to assets up here and bring this up, and let's go to nameplates. And so, can we see this over here? Yeah, there you go. So I've got this back plate here. I've got this left edge and the right edge. What's piece 2 over here? I'm not sure what piece 2 is used for right now, but I've got piece 0 and piece 1 right here. Oh,
Yeah.
this I think is a shadowy thing that comes in. It's just a subtle piece that comes in. And so what happens is I crop this thing to the right length and the right size. Then I put these two on the sides to make it look like, I don't know if this is easy to see or not, but it's basically the wooden edge of it with a with a metal kind of edge to it. And it just is this small, subtle little effect. So all of that work is done. It's like, and yet it's like sucking up. It's sucking up the processor power. And it's not only just this, it's these other two base animations draw by index there. So, yeah, but I was thinking, well, let's take this out and let's change it. What's going on with here? I want to know what context, why am I saving that? I don't understand why the save filter is here. What's my context filter? I need to look that up. I don't remember why I have that code here. Well, you know what? Let's maybe do this. Let's try this just for fun. Let's just do the same test we've been doing before. See if we can have an impact on it. So let me refresh. Here's a refresh. Oh, yeah, that's not working. I can't do the refresh because I'm not running anymore because we killed them. So maybe let's restore them here and here. Love the beard. Well, thank you very much. Lundrigan. Let me know how to pronounce your name, what the best way is to do that. All right, so let's hit start here. We'll start it. Let's see if we can get, we'll see if we can get to the bottom of it. Yeah, I guess commenting those out doesn't really make a lot of sense that would be causing the problem. Because everything, all the other code is going, and the drop cropped by index shouldn't be messing with the filter. And this kind of thing should be incredibly fast. That shouldn't be a GPU hit. All right, we're starting up. Let's switch to the drag and front overlay. Right there. And you were asking, are we seeing that error message in there? So let's see if we can do that. I'm going to call initialize player data on it. Let's see what we're doing over in the GPU space. There it is right there. So wait, that's low.
OBS though, you'd be looking at Chrome for
We're now over in Chrome here. By the way, Chrome is totally being nice right now. Okay. Of course, we don't have. It says waiting for it to. Oh, I don't think I need to restart to get SignalR to hook into this. The existing SignalR, the app up and running, already thinks it's connected, but it's not connected to it. How you doing, baby?
I need.
Where's your hand out like that? What do you need?
Because you didn't.
What is it? What's this? It's floating over. Jesus. All right, she's gone. She just left like that. All right. Okay. What do we got? We got to start that up again. Here it comes. Click initialize player data now. Now this should work and disappear. Come on. It did not. Oh, there it is. It just took a little longer. Okay. So let's see what's going on here. What's happening over in Chrome space here? Yeah, I'm going to say that's our guy.
Okay.
That's it right there.
So now this is nice because we have an isolated sandbox now in which this happens. This is not necessary to have OBS not running in order to see this problem.
Yeah.
So Chrome has as much trouble with this as OBS, which is nice.
You're right. It is nice. Let's answer your question. Let's bring up the inspect window. And everything is slow, by the way. I can totally feel it. It's like the mouse is slow. And the answer is we do not have any error messages in here.
Okay.
And yet, look at what's happening. Now, if I come in and watch this, I'm going to turn off the nameplates just by using the UI. I'm going to say, show only one nameplate. And look at it drop down.
Wow.
It's like that's the difference between 4 nameplates and 1. So something crazy is going on here. That was my wallet that just flew by. Yeah, came back. It feels
wallet is boomerang.
Feels much lighter than before. Yeah, it's like a boomerang, isn't it? That's a little. That's significant. That's like crazy to me. So there should be only one. Is there one now showing on there? Yeah, there's just the one nameplate that's showing.
Fred's in the way there, but I'll trust you.
Oh, here, let me show you, and let's take the last one away and watch the GPU on it. So we're at now at 18.5%. Let's take the last.
Too white, it's gonna hide.
Yeah, here goes. I'm showing the last. I'm hiding the last one. I just hit it. 8%.
Yeah.
Is that crazy?
So, that is mad. But I'm given to wonder now, given that we've got this happening in Chrome, reproducible in Chrome, that's good. I know nothing about this, but I'm curious, does the performance tab in the debugging tools tell us anything interesting?
Yeah, let's find out. Let's do this. Well, we can do this. I think that the information that it would have for us is not going to be immediately useful. Because I have a theory on what's happening. My theory is, in order for all of this to make sense, the only thing that makes sense to me on this is its frame rate is just outrageous. It's drawing it like crazy, like a whole bunch of times. That's the only thing that makes sense to me.
So we have some variation on our drawing mechanic that doesn't take into account, it's drawing it as quick as it can, not every X frames.
Yeah, so let me go in. Let's just go in and I'm going to turn on all of the name tags, and we'll do what you're suggesting. But I think that the problem is it's going to say, okay, yeah, here are your 4 lines of code where it's sucking up the time. It's not going to tell us anything new. The information we need is going to be kind of outside of that, is what I'm suspecting. But all right, so let's. What are we doing here? Do you want to do a memory
I think it's performance
snapshot?
just to the left of that. Now, I don't know what this does, so it's...
Enable advanced paint instrumentation. Slow. Let's do it.
Okay.
I'll go for 10 seconds. All right.
Okay.
Yeah, I don't like the UI on this, and it doesn't work the way I want it to work, right? I want it to be like, okay, here's your big, I want it to show me the most important piece of information first. Like I want this, now I want to be able to double click on this and now drill into scripting, but I can't work in this UI, so I get frustrated. I can't even click here. It's like the summary is useless to me, and it could be so useful. So now I have to come over here and bottom up. What is it? Run micro tasks. I've got draw image here happening here 17.2% of the time. Draw cropped by index, draw by index. And look, there's my show nameplate. At least it got me there. Right?
Yeah. But I mean, it's still saying only about 5% of the time there. I mean, mind you, is 5% significant given, it might be. All the other draws might be, a lot smaller than 5, and there
when
might
you're
be so
saying
many.
5% of the time, I'm not sure what you're talking about. What are you referring to? You go down here.
To the left of show namespace, there's a total time 5.4.
Well, yeah. Now this is actually kind of super interesting. Look at this. Show nameplates. Does that make sense? Show nameplate 5.4% of the time. I'm trying to figure out how do I get this big jump from here to here when it's just doing. No, wait, hold on. Maybe I'm not quite understanding this. We're coming from our animate. The same thing. Okay, so this is what this is. This is actually confirms as well what we've taken a look at, and that draw by index and draw crop by index. Those are those lines inside there that we were looking at, right? How much they take up. They're taking up some time here. They totally are. Whereas draw is taking up almost nothing. The draw method, that's in Sprite Proxy. Draw by index is in part. I thought draw. I thought draw called draw by index as well, but maybe it does not. Yeah. And then the other thing is it goes into draw image from draw crop by index as well, which is taking up some time. Yeah, I don't have a clear sense of exactly how to read this. Let me go look though. I want to go into the code and look up draw image, the draw image call from draw cropped by index. I want to go in here. Oh, that's just straight out of context, so I don't have any control over that. Yeah, so now I'm back to essentially, all right, so at this point, I feel like this is similar to what my prediction was, which is, hold on a second, there's noise out here and I've got to reach over with my foot and close the door. Boom, look at that. All right, this is similar to what my prediction was, is that the information here I thought wasn't going to help us. Right?
Yeah, it doesn't seem to be terribly useful, does it?
There's some other bit of information maybe around here, like the number of calls, that sort of thing, that can help us out. Fill text, notice I've got a measure text in here. Where's that coming from? Draw game time and show nameplate. What's interesting about measure text is that's something we could cache. Gain a little bit of performance benefit in here, the call to measure text. This 2.5%, I'm not sure what that is of what that total 100% is of. I'm assuming it's of the total time maybe, but I'm not 100% certain about that. Got a timer fired in here. The update screen is taking 41.5%. Yeah, it is not my favorite here. Group by activity. I just want to see what these do. So JavaScript is here. Draw image, fill text, draw image. These two, yeah, we're just going to go back to show nameplate. And then the draw function but it's much less than the others. What's call tree going to give me here? Animation frame fired. Well, this is actually a little
more. This is more useful because it's top down, isn't it?
Yeah, this is how I like.
Direction.
Yeah, this is kind of what I'm looking for here. This is exactly now. Okay, could they have put that one over here? Could they have given me access to that from here? Maybe. Yeah. Oh, I don't like that. Did you see what just happened? I had this whole thing open.
Oh, it collapsed it.
Yeah, and I went here, and then I went back here, and it's like, yeah, I'm not going to give that to you. All right, so at least now I understand a little bit more about how to go through this. Let's keep going. Update screen, and here we go. Look at this. So draw time plus effects is taking up some time there too. But now at least
less than half of show nameplates.
Yeah, this is so much better now, though, right? In terms of understanding what's going on here. This is, yeah. I don't know why they opted to do bottom up right there. That I don't find that useful at all. Okay, show nameplate. There, draw crop by index. It's essentially saying what we discovered as well. Damn it, Miller, you have me criticizing UX. Now you have me criticizing UX. Yeah, I don't know. I'm like, good. It's good. And then we finally get down to here.
So draw index by value and draw by index. Both mostly delegate to draw image.
That's really happening.
is in the house.
Way too happy, Michael. I need you to stop right now. Thank you. The guy always tries to fly over.
He does.
He's
Never worked yet.
I don't even think he's got a license for that taco.
So I'm reading these percentages, and each one appears to be the percentage of the whole rather than of its immediate parents. And if you assume that, then draw image in each case is the vast majority of its parent, i.e. draw by index and draw cropped by index are inherently fine themselves. They don't do a lot except call draw image, right? Draw image is beyond our control. It's on the context. And therefore, this leads me to believe that you are correct, and we are simply calling these a lot. They are efficient in and of themselves, but maybe we're just calling them too often. The frame rate, as you say, is just doing this a lot.
Yeah. Yeah. And I'm like, I don't get that. I don't get that. I'm like, why would draw image be so much slower? I'm wondering, like, I'm playing with ideas and I'm thinking, is it like, are we handing it images with this crazy .dpi or something? Like, is the image itself messed up?
We can test that by replacing the images.
Well, you know what? I already ran PNG Gauntlet on them, so they should be good.
They're not very large. That's true.
Yeah. Yeah, and they're not very large, right? We were just looking at the files are not big. And I'm pretty sure that's actual size of it right there. Yeah, that's the actual size. Looks like chat's hiding that. The chat window's blocking that a little bit. There.
But we certainly have much bigger images. Thinking of a certain battle unicorn.
Yeah. So you know, I'm like, I think the next thing is to look at is like, okay, how many times per second is this thing called?
Yeah, it's a shame we can't obviously see that fact.
Yeah,
because that's kind of one of the things I'd hope would be being calculated. There's an event log there. Is that events as in real events or events as in counters for things getting called? I don't know.
Animation frame fired, so that's like an event. This is the whole log, I think, is what's happening. So you're seeing what's happening here. So the animation frame is called. We get into update screen, draw time, and then we get into show nameplates. So this is like one call of it right here. And you can see we could actually calculate it. So like animation frame fired here. So these looks like to be milliseconds.
Yeah.
So that is this is a 1/10 of a second difference here between here and here.
Okay.
Does that look right to you? And it looks like about
I haven't quite got the resolution to see it, I don't think.
Okay. Basically it goes from 3888 milliseconds to 3787 milliseconds. That looks like from the beginning of the, hold on, let's move to the end and look at these. This is a different, yeah, it looks like a difference of about 7/100ths, almost a 1/10 of a second. So 7/100ths of a second is what I'm seeing between these two here. So yeah, there goes that theory, I think. Although, wait a second here. This one is, actually this one and this one are,
Scroll down just a little bit there, Mark. We can't quite see those behind Fred.
I don't seem to be able to scroll down.
Oh no, you're at the bottom. That was.
Hold on. Let's subtract these two, because this one actually, I want to do this in the calculator. I've got two animation frame fires here, and the difference here is much less. What's the difference between here and here? Oh yeah, way less here. Holy cow. Let's double check my math is right and I'm seeing these numbers correctly here. The first one is 10277 milliseconds minus 10252. And that is, divide that by, that's 25 milliseconds.
25 milliseconds.
So 1,000 divided by 25 milliseconds is equal to 40 frames a second. That's doing 40 frames a second right there.
Okay.
Okay, so now if that's true, why is that? We need to figure that part out. That's coming from, so we looked at if we went back to the call tree, it's coming from animation frame fired function call. It comes from animate FPS in game.
Okay.
That's where it's coming from. So let's go figure out what's going on with animate FPS. What's bizarre? Two? Shirley, by the way, said I missed one of the things he said earlier. It was funny. I was watching a stream the other day and suggested some layout changes, and he did them. In my head, I just had Mark telling me. And yeah, the kids are, Karen says, the kids start blaming things they interact with at about age 3. That's bad design. Yeah, Sex Positive says she gets them all. Mr. Announcer Guy knows what is what. Poor zombies. All they want is your brain, Sex Positive. Okay, so we're running at 40 frames a second, which we should absolutely not be running at. What's bizarre is it says, hey, go look at game. And I'm like, game is the ancestor class for all of these kids. That doesn't make sense to me.
But do different CSHTMLs or different games initialize a value in-game to a higher or lower frame rate by default?
Well, that's feeling like where we might be at. So FPS interval is here. Change frame rate is here. Who calls change frame rate here? Well, this is if this is from a method called change frame rate. Anybody else? Start animating, and then that's the last call to change frame rate. So who's calling start animating? We've got it a run from game at 30 frames a second. We can change that default. How are we getting to 40? What looks like 40 frames a second, though. I guess it could be not so accurate, though. Hey, Puddings came in. Oh, Pudding's probably wondering why this show's not happening. Oki's bot. Yeah. Whose fault that could be. We shut everything down. We shut everything down, and we're in the middle of looking at some code here on this. But why wouldn't the show part work? I don't get that. Why would Sex Positive get one? Why would she get one? Is it because, oh, I killed it? We didn't save? I don't know. I'm like, sorry, I'm like, my brain is like going after like, different problems like squirrel.
Many problems at once.
Yeah.
We're spawning new instances of Mark. Just one for that one for this problem, one for this other problem.
Yeah, this.
No, just one.
Just one. We can't have more than one timeline. Maybe it's because I'm.
5 of that.
Yeah, all powerful. Whoa, whoa, whoa! Look, Pudding's coming in now. Change
problems that solve themselves.
Yeah, I don't get it. Let's go back over here.
Was that the only call to change frame rate?
Yeah, that was it. We went through those. So change frame rate, just to review, I started there and I went through and I said, okay, it's got a bunch of calls in this change frame rate signal R function right here. So this is called from signal R, so we can dynamically change the frame rate. And it's called from start animating. And start animating really only has one call right here. That also means, though, that if we come into our task manager, see this 40%, if I come in, let's just double check and make sure we are drawing full on. There it is right there. So we're drawing full on right there. If we go take our frame rate, and I'm going into the app now, right here. I'm going to change that frame rate. Let's see what happens here when I drop the front overlay down to 5. Oh, big change. Yeah.
Okay.
It's a big change, but still, the whole thing, Rory, doesn't smell right. That call is taking way too long. And I'm almost thinking I'm taking a little bit too long to solve this problem and look at this. I guess one might as well throw, since we're doing all of these things here, because this is kind of this curious kind of thing. Let's open the backplate up and let's see what kind of information we can get from this. I guess we could also we could replace this with another image, for example. Image information, pixels per inch, depth is 8 bits per channel. Yeah, there's and what's the DPI on this?
Interesting. On disk 40 something K, in RAM 134. Does that suggest that there's decompression happening in memory?
Yeah, I think so. But I don't feel like that's the problem either. I'm like, where's my DPI stored though? I don't remember where I can find DPI on this. It's maybe in a different part. Oh no, there it is, pixels per inch. So it's 200 pixels per inch. That's the DPI. 6 Positive says, yesterday I gave my daughter pudding, so she gave me an 8 out of 10. Mark Miller got 12 out of 10, and frankly, I'm pissed. Wow. I'm disappointed. 6 Positive certainly says 6 Positive. Adoption. Okay, so yeah, I don't think
he's suggesting adoption on the inroads, i.e. not your daughter, or alternatively, he's suggesting that you have her adopted.
No, I think it could be both. So, yeah, I'm like, my thoughts on this, Rory, are change this up radically so it's not sucking up so much bandwidth. That's kind of what I'm thinking. Change the way it draws. Just put a border on the background of this thing and be done with it. I guess
you're saying draw a filled rectangle.
Draw a filled rectangle.
To supplant your awesome graphics.
Yeah. Or at least maybe just think about it for a while. Right? We've done like we're at a point where it's like it's not like obviously our code is the problem. Do you know what I'm saying? That's it's it's simply we're drawing it. The GPU. This is the mind-blowing thing. The GPU cannot handle the drawing of 1, 2, 3, 4, 5, 15 images because there's 15 images plus the clock at 30 frames a second.
But at the same time, all the coins, the drones, Fred, everything else.
Yeah, it doesn't make any sense.
The straw that broke a fleet of camels' backs.
Yeah, it absolutely makes no sense at all. It's mind-blowing to me what the data we're looking at. That Chrome and the browser and basically the GPU is choking on these name tags, drawing these name tags, these 5 name tags. And proportionally, right, if I only have one of the 5 up, it's like, okay.
Yeah.
And if I drop my frame rate down from 30 frames a second down to, say, 5 frames a second, it's okay. It's absolutely stunning to me. It almost makes me want to, like another way to solve this would be to create like a bitmap that holds all of these, right?
Yeah.
And when only these change, we update the bitmap, but otherwise we just draw that bitmap the same way every time.
I mean, the crazy part is that you could, in fact, as you say, have a single bitmap for all of the pieces. So instead of 4 separate images, you'd have 1 image. Still have the text being written on top as it is. Space them out. And are we saying we'd get a quarter of the problem?
Yeah. Well, I don't know. The thing is that these have to change. The size changes depending on are we in combat or not. Do we have temporary hit points? What's the text inside that we're putting inside? So that's there. Pudding says no one should use Edge. Create a static image for the nameplates. Display static image. Yeah.
They are static images, aren't they?
Well,
I mean, individually, they're a composite of 3 or 4 static images.
Yeah, they're just static images that are put out. One of them's cropped. So that this background piece is cropped to figure out the right size, and then the other pieces are added on there. There's my daughter coming in. How you doing, baby? You good? I'm good. You want to say hi to everybody? Come over and say hi. You look like you're... Oh, look at this. Just in time. Copperbeardy's here. Look out. Don't get wet. Yeah. Oh, look right there. Look what's drawing. This looks growing. That's cool. You're going to eat it now. Yeah, that means Copperbeardy's here. Been listening from the bath and the sound of the panther. I think you need a shower. All right. I think that's more information than we needed to know, Copperbeardy, that you're in the bathtub right now.
I'm going to go take a bath.
All right. That's weird, but okay. Thank you. Appreciate that.
Separate tubs.
All the
Separate
colliding
tubs.
statements.
So Pudding says no. She gave me an 8 out of 10. Pudding Raider. Yeah. That wasn't the one who was the Pudding Raider right there. It was the other. It was the older, the surly 17-year-old. Okay. Yeah, I'm kind of in a comfortable place, Rory, where I'm so in shock about this and in disbelief that I just kind of want to hold on to that shock and disbelief for a little longer before I come at this, because I want to try just a couple more creative things, creative approaches to this, but I don't think they're necessarily going to yield anything. But I want to just throw different curveballs at this space and see what's going on. There's a possibility I got another idea.
And what would that be?
I have an idea as to why this is happening. And it goes like this. Because it draws these so quickly, the frame rate goes up. But if it's drawing it, if it takes more time to draw, the frame rate drops down. Okay, I guess is what I'm saying. Is this even beginning to make sense at all? I feel like it doesn't make sense if I also take into consideration the fact that we really saw it jump a lot. We really saw it jump up a lot. It was crazy how much it jumped up. Wait, one more time. Let's go in here. Let's do a performance. Do we have our last one? It looks like we don't. I don't understand why that's the case, but anyway, let's do it. Starter profiling. Okay. I do not know why bottom up is the first thing here. The call tree.
That is strange, isn't it?
The call tree is the one we want. All right, so here we go. 72% is spent doing the animation. Garbage collection is happening as a big chunk of it. Composite layers, what's that? I don't know what composite layers are. All right, animate FPS is up here. The function call and draw. What's interesting here is the drop between here and here.
Yeah. And
even here. I guess, right? I don't even get this right here. This means this is all code we don't have access to. Just the animation frame is fired, the function call gets here. It's bizarre to me that so we're 72% animation frame fired, half of it is our drawing and another half of it is something else going on. Do you see what I'm saying here? We finally,
things that are apparently not siblings of our thing.
Yeah. I don't know what that is. Then we get in here and we go from animate FPS to draw game, and check this out. Request animation frame is half of this 36.4%.
Hang on though, because that second column that you're looking at is total time. So relative to total time. You've got one to the left of that which shows individual self time.
Ooh, nice. I like that.
So draw game is 0%.
But request animation frame is insane.
Yeah.
And I'm wondering though if request animation frame is measuring the time between then and the next time the frame's available, or is that actually the time it takes to make that call? I guess it would be the time to make the call. That's crazy that it would take so much time. And then in draw a game, I've got, in other words, now we get to the part where we're actually updating, Rory. You know, this much time is spent updating of the total time.
So the way I'm reading that is that draw game itself takes not a lot, virtually nothing, and its child call update again takes nothing, and it's not until you start getting down to show template that there is actual, occupancy of the total.
Yeah,
you've got a 1.3 and a 4.1 there.
Yeah, so the self time
So
here is the big.
there's a lot of A equals B equals C, and A, B, and C really don't do anything except call each other. Then you get down to D, and okay, now is where the meat of things happening actually starts to occupy time.
Yeah. Yeah.
So ultimately, those two draw images take 4.1 and 2.3% of the total time.
Sorry, I moved things around a little bit here. Let's see, what do I want to look at here? Yeah, I'm trying to figure out something that is the best way to look at that. Yeah, that's a great observation, Rory. Right, so we're here, update screen, and the
So I believe what that says is that the update screen and all of its children totaled together take 17.1%, whereas the update screen itself only takes 0.1%.
Yeah, without the child calls, right? Exactly. That's how I'm reading that to be as well. The same thing with show nameplates. It's the calls. The show nameplate here is kind of the problem. Then once we get to show nameplate, we kind of divide some things up right here. And so 4, 5, 6, 7, 8, 9, 10. Yeah, I'm looking to get this total here. So you've got.
Did you see the draw cropped by index and draw by index? Their self time is almost negligible. It's things they call which take the large part of the time, and that then is calls that we don't get to control.
Yeah. JavaScript, draw context, draw image, GPU.
Yeah.
Performance. Interesting suggestion.
That's the sprite sheet kind of approach, yeah.
Well, this is definitely not what we're doing.
Well, I mean, we are using lots of different images, but in fairness, if lots of different images was going to cause us a problem, it would have done so a long time ago, right?
It's interesting.
These 4 or 5 images do not put us over the edge.
Yeah, it says this way you avoid too many context switches.
Interesting.
All right, hold on. That's the only answer for it. The context switch. So in our code,
you did see a saving of a context and then a restoring.
Yeah. There's this filter thing right here is kind of interesting. I kind of want to comment it out. Is what I want to do. Take the save filter and also the restore of it. I just want to see if that impacts the lower level methods. Right? Yeah. If there's this reassignment of the filter there, and see what happens there. So let's do that. I don't remember why I added that line of code. I don't even know what it does now. I've completely forgotten that. So let's see. Let's go here, refresh this. Let's initialize the data again. And look at before we initialize the data, let's get this up on screen so we can see this. So here, we're down here looking at this.
6.5, 7.5.
Yeah, right there.
No.
That's what we're looking at.
Still sub 10 value.
Yeah, I'm going to click on initialize player data and see what happens. Just going to do the same thing again. Oh, yeah. Yeah, it's just insane. Oh, look at the clock. The clock is, oh, you can't quite see it because the chat's covering it up. Hold on a second. Let me bring it back over here. Look at the clock. The clock has changed color. So that means we're doing some sort of color shifting. I
feel like the context, the shift of the filter thing is sort of a bit like I'm about to, hang on a second, turn that off. It's like I'm going to do a color shift. I wish to shift to red. So what I'll do is I will shift to red. If I don't store what I had before and shift back, then everything else I draw forevermore will be in red.
That might be true. I'm calling shift color on the sprite right there. And the shift color on the sprite, let's see here. Where's that sprite called? Where is it actually drawn? I'm not sure what's going on with this. How is the sprite color changed? Because I don't see where it's accessed. Is it drawn somewhere else? The nameplate sprites. Are we drawing the nameplate sprites anywhere? Yeah, we've got the draw cropped by index. Again, we've been in here before, but and then it just goes right out. Right? There's nothing else, no other code that's happening there. So that also kind of means we should be able to do this, get rid of this, even though I know these aren't the lines of code that are causing the problem. But I'm trying to figure out, is it maybe draw by index has the color shifting? Is that what's happening?
I mean, I'm not sure that this is necessarily, well, I guess the Stack Overflow answer suggested that context switching could be causing GPU issues. We use context switching, it would appear, to allow us to store a kind of an undo stack of state so that we can decide to shift colors if we want to, and then just undo with our finally statement, which says put it back as it was.
Yeah, that kind of looks like what's happening, but what I don't understand is exactly how that is happening. Between what the save filter on the context actually doing, why is that changing the clock color? Because the hue shift is only going to happen if it's a color shifting proxy. Wait. I wonder if there are overloads of these. Could that be my problem?
Well, hang on. Doesn't the nameplate represent something that is hue shifted?
Yes.
So if the nameplate's drawn sequentially ahead of the clock, then the nameplate gets to shift the hue to, let's say, red. And because we're no longer undoing that fact, when we finally get around to displaying the clock a little later, it just uses the context in whatever state it is.
Yeah, I don't think that's, yeah, I guess it must be happening, but it's not the way it should be happening. So draw by index, yeah, it's only in part here. There's no descendant of this that's out there calling that. Also, there's no hue shifting in the draw by index. The hue shifting does not happen here.
Sure.
The hue shifting happens when the sprite is drawn.
What's context restoring from at the end of that if we're not changing it?
This line of code is not executed.
That's the scaling.
Yeah.
Right. Yeah, of course, and we know that's not happening in this case.
Yeah,
okay.
that does not appear to be happening. We commented that out and still had the problem. I wanted to go over, look at hue shift, color shifting, proxy, whatever. Look at that in a second. Hue shift. Right, what is it? Shift. Maybe it's not that. It's color shifting. There it is. Color shifting sprite proxy. It's here in draw, this draw call for the sprite itself. Okay, and so that's what's going on there. That's when we call this shift color. And shift color, we come in here and get the current hue. What's interesting is we must be calling this. So that must mean we are calling the sprite's draw from inside of the nameplate. But I didn't see a draw call in here. Let me just double check that. I'm going to do a search from here, see if I can see a draw in here. It's not the same thing. This is just the draw method. Yeah, that is what would ultimately lead to it. If there was something like that, nameplates.draw. Can I shift tab backwards to see any other calls in here? Now we're in dice layer. Let's go back forward again. We're in front game. Front game, there's the back effects. There's the blood effects. All front effects. We're never calling the nameplates.draw. Clock layer effects draw. And we're outside the file. So there's no other call to the sprites in there. How are these color shifting pieces occurring? I need to understand that. Back over to front game. Draw nameplates, show nameplates. This sprite, where is it drawn? I want to just see how we're getting this sprite from above here. We're getting it from nameplates.sprites. Base animation, draw, crop, and index. Okay, I got to come in here again. It's just going straight into context.draw image. So draw, crop by index. I don't even understand how it's color shifting that. Oh wait, sorry, it's here. Yeah. That's the line of code. I'm sorry, shift color, I wasn't looking closely at that. That's calling this piece right here where we're context filter setting it and changing it. So we're doing the hue rotate there and we're never restoring it is what's happening.
That's what finally should be doing, right?
Yeah, so wait. And we commented this out though. Hold on. Maybe we didn't quite do this combination.
No, we commented definitely the let and the finally piece, which led to, I think, the color change lasting longer than just the nameplates.
Yeah, let's see what this does. I actually have a good feeling about this.
So now we're not going to shift at all.
Yeah,
thus there's no need to restore.
No color shifting at all. Just see what goes on here. Yeah, the color shifting. All right, bring up task manager.
So is this then, I mean, if this does solve our perf issue, does that mean that the problem is having too many things hue shifting in different directions on screen at the same time?
Yeah, look at that. Do you see that, Rory?
That looks low.
Yeah, it's the hue shifting.
Because normally we hue shift, it's like for an animation, so there's lots of things, but they're shifting to the same thing. So it's shifts per second almost.
Yeah. We are color shifting. Surly's asking what color shifting is happening on the nameplates. We're color shifting to match the color of the player. Yeah, I'm killing that. That's super interesting. We've done hue shifting elsewhere. In fact, holy cow, we do hue shifting like crazy on Sprinkles. Sprinkles is giant, and we are hue shifting. Isn't that a one-off shift? No, I don't think I understand what you mean by a one-off shift. We're shifting the hue to match the color, the hue of the player, so that their name tag is the same. But I'm just going to change this to a wooden background is what I'm going to do. So it just looks like a wooden board. That's what I'm going to do. Maybe draw some black text behind it. I think I'm going to do it now. Are you saying the shifting changes constantly? Well, kind of. Each time we come in, we called shift color right here.
Yeah.
And then we restored it. It was not liking that color context color changes each time we came in.
So if we think about this in terms of, let's imagine we're right, that it was 40 frames a second, right? There are 4 or 5 nameplates, so that's 5 sets of 40 color shifts
plus the
each
ends.
and every second.
Plus the ends. So there's you know, multiply that by.
But if you talk about
3.
sprinkles on our own, right? Sprinkles is going to sit there and be color shifting, but is still just 1, maybe 2 entities.
No, sprinkles
doing that on.
Well, wait, is it 1?
Because you got the horn, wasn't it? Or
no, I think yeah. I'm just trying to remember. No, I think you're right. Yeah, sprinkles is 1 giant entity. That's right. It's just 1. Yeah, that's crazy. But we use color shifting all over the place, and as it didn't seem like it was that expensive. Like we use it. We use it. I'm trying to think of what major effects we use it on, but yeah, interesting. I'm gonna have to give that some thought. Sprinkles has horns and tears. Yeah, we do color shifting on sprinkles. So like if we bring in sprinkles here, well, let's do this. Let's, that's super interesting. Yeah. I want to fix this now. That's what I want to do. Because I'm like, let's go out to elements, envato.com. Let's go find a photo template, get, was it wood background, something like that, wood grain, maybe like that. Let's throw it there. And can we start music now? I wonder if we can do that. Let's see what happens. Sounds like we can. Okay. I'm just going to use this top piece up here. Come on, gotta change this to rectangle. Pop that. I want to make it darker, and I want to just drop the scale down a bit. So it's interesting, the I think it was a combination of the cropping, maybe. Well, no, because it also was drawing by index. Yeah, I just didn't like that at all. I think that can kind of work. Here, let's undo that a bit. By the way, my image editing program, it drops substantially based on when GPU is taken. Its performance is like, it's like I can't do anything. So even dragging.
Well, that makes a certain level of sense, doesn't it?
Yeah, I don't know. I'm like, come on. Just trying to drag that down there and save that. I don't want to darken it as well. All right, let's make it darker. And let's remove some of the color from it. There we go. About there. Let's make it, let's darken it up a little bit. Let's also make it about the right size too. Let me do this. Let's select everything here. So we're working with something much smaller. How big is the one that's out here? 358 by 92. So let's resize this to match that. By pixels, don't lock them. Where's my lock button? Okay, see the lock here? Here's another UI issue. This lock button over here, it's too far away from that.
Yeah.
Right? I should be able to click this lock button right there to get rid of that, to unlock that. All right, what did we say? I don't remember.
358 was the first number. Was it 92?
That's what I think.
Not sure.
358 by 92. Like that. Let's go back and double check that. Yep, 358 by 92. Is that Frank there? Hey Frank, how you doing, buddy? Bring that up. Okay, so that's what we're looking at. Much easier to work with that smaller piece. I'm just going to darken it up just a little bit so it's got a more consistent kind of look across it. And so that we're looking for the white lettering to show up better on it. Let's turn down my opacity of this tool.
Yes, Frank, you join us during the creation of a wooden slab to replace, at least temporarily, the nameplates in the Dragon Hunter show, because we have determined that an attempt to color shift those templates is causing us to drop a huge amount of GPU on the problem.
Yeah.
It's absolutely mad. It would seem that we're color shifting, I think, is it 3 or 4 pieces of the existing nameplates? We're color shifting each of them to different values for each of the 5 people, 40 or so times a second. And this particular exercise in just this one section, never mind the color shifting we're apparently doing elsewhere, this is causing a lot of our performance problem. We've got 10-20% GPU just being lost.
There we go. And I just ran PNG Gauntlet on it. Normally I would never touch PNG Gauntlet during a live stream because it sucks up every single CPU out there. But let's see what happens now. Where is here? Let's refresh this and see how it looks. Initializing player data. Okay. Oh, wait, there we go. I was going to say it didn't quite work, but now it looks like it works. And I've got some contrast here. It's not bad between the foreground and the background. So it gives me that kind of rustic look a little bit. I got to change the ends, but not too big of a deal. Whoa. Oh, this is, I'm sorry. What the heck is that? Don't worry. It's just, it's zoom in right there.
Okay.
So I think not bad. I do want to put some dark black text behind this. And since I've freed up my processor, well, let's verify that I've freed up my processor on that. Yeah, look, this thing used to be up at 40 or 50% when we were color shifting it. And now the GPU is way down. And I'm like very happy about that.
Essentially, we commented out something like 6-7 lines of code at most, and that includes like curly braces too. And yeah, presto.
Yeah. I just want to be like, today I learned that color shifting.
I mean, we need to be a little bit careful what we
context.
say here, because it may not be the color shifting specifically, but definitely context switching very rapidly. It has caused us an issue, and that's why we were doing it in this case.
Yeah, context switching. I'm gonna draw a frame. Sucks up my GPU.
I feel like we've made a good discovery today.
Yes, and I agree. I'm with you. I'm with you 100%. I guess this won't be a to-do. This will just be an important comment like that. Okay, so there's that. We don't need to try finally anymore. I'm going to kill that. I'm going to kill this. What'd you say, Rory?
I say that's true. We don't need to try finally. So actually, at some level, that might even give even more, albeit a slight performance increase, because
Sure.
no need to maintain a stack of any kind.
I want black text behind that, just a little bit. I want to make it look like it is kind of indented. Is what I think I want it to do. So let's look at where we are doing our text out on this. Measure text, we're doing there. Look for like a draw text call, I think is what I'm looking for. See if I can find, well, let's just have next reference on the context, see where we're using it. Here it is, fill text. All right. If we're not hiding hit points, then we show the hit points. Okay, so now what I want to do, well, that's fill text call, so I don't have control over that. So, I want to extract this. Whoops, no. Extract to method in class. And we're going to call this draw name text, like that. And the color we're using, I think all of this can go inside of there. I don't think we care about that being set up in advance. Oh wait, we do for measuring. Sorry, we do for measuring. We need to measure in advance. The fill style is the piece I want to change. That's what I want to do. So I want to say, well, actually, I don't need to set fill style for measuring. Like that. So I'm going to take that out. Okay, cool. So now down in here, I'm going to say my fill style is equal. We'll make it black first because I want black in the background. And I want to offset the black. And I think I want it in the upper left. So I'm going to say name center -1 and name center Y -1. So then we'll do that. Then I want to do the same thing. I think I want to also do my hit points up here like this. And we'll do the hit points. Do its offset as well. And then put this right down here without the offset. And I think that's going to give me what I want. Just a little bit of a shadow of context to make the letters a little easier for our feature receptors to identify. So
is this that effect where the parts of the text that fall over light will reflect using the black, and the ones that fall over the dark you'll see the white? So there's contrast everywhere, no matter the variance of the background.
No, you're only going to see contrast in the upper left. So you're seeing it.
Oh,
you're seeing the black in the upper left a little bit here is what's happening. I might do that. I might change that to a 2, and let's just see what happens. Let's do this. Let's do qn for a constant of type number, and we're going to say this is the offset, shadow offset. We'll make that -2. So we can come back quickly and change that later. You know, I was thinking of doing something like this when I was writing the -1s all the way through. And I didn't do it. And I should just know. All right, so there's my shadow offset there. We could also do this. Draw, whoops, rename, draw, name and hit points, like that. And do it again here, but with shadow offset being 0. Okay, let's refresh. Initializing player data. Good. Yeah, I think it's better. I did too.
That's good.
So you can see it just makes it a little easier to recognize the text. I can also do it the other way too, which is kind of potentially interesting to do. In fact, let's actually do this. Let's change this to a let. Then we're going to say shadow offset is equal to 2. Like that. And then we're going to draw one more time, but we're going to change the color. We'll keep the fill style, but we're going to say context.global alpha is equal to 50%. Like that. And then when we get out of that, we're going to come back to a 1. Okay? So that's going to now give us a shadow on the other side, but not as significant of a shadow. Let's try that. Just small little changes here, but the way our feature detectors are working, we're looking for that high contrast when we're reading. So I want to give it both a rustic medieval feel to the nameplate, but I also want the text to be easy to read. And yeah, it is easier. I can tell my feature detectors are not as high. They're not as high. They're a little more happy. They're not as active. And so there it is. So now we've got those names. The text is relatively easy to read. I picked a font that had both a medieval theme to it, but also was thick enough and could convey information at a small size. So I think we are in a good place.
I think so.
I think I want to stop running this because this is sucking up more GPU. And I want to go back and refresh in the main thing. Let's do this. Let's just go out to Google like that. So that just at least not sucking up the CPU anymore. Let's verify that that's the case. Yeah, Google Chrome is down here now. Let's go into OBS and let's refresh in OBS. Let's see. Looks like somehow I've lost my overlay, my drag and front overlay on this page. I'm not sure how, if I deleted it or something like that. Yeah, a little bit interesting. All right, no biggies. I can add it back in. Add it's a browser source, add existing. And it is the drag and front overlay. And put it up here. I want to drag it down there. Okay, so let's just double check. We're going to refresh that. Make sure it's good. We're going to let's refresh the other ones too, as well, the other layers. Refreshing dice. So GPU's at 99%, but this is our OBS.
The page itself is low.
Say that? Yeah, the page itself is low? Yeah.
Yeah.
It's not bad.
That's the thing we're focusing on.
And now let's do the back overlay as well one more time. Refresh that. There's the refresh on the back overlay. Yeah, so here's what we're watching. That guy right there. And now we're going to choose initialize player data. We want it to stay down around 40-something%. That's what we're looking for. And I think we've achieved it. We've got the name tags up.
Well, I mean, that was definitely 60% before. So
yeah.
Even if we're doing approximate, we've saved a third of our GPU.
Yeah, it's great.
For this one process. That's huge.
Let's come in. I'm going to add 22 health, which is going to tax the system. It's going to put stuff all over the place. So now it goes up as expected, but it should, when this is done, drop back down to about 40. There you go.
Yeah.
Okay. Rory, I think we, not bad. I think we figured out, we got definitely into a better state, is what I think we did.
Absolutely.
So, all right, cool. Let's go back to what we were regularly scheduled show, what we were going to do. Yeah, much better. Much better.
Mark, I'm afraid we've reached the time of the day where I'm afraid I'm going to have to disappear.
No worries. This is we got to get you a better way to leave, right? Like, I want to get you a remote control scene switching option so that you just hit a button and then it's all of a sudden like, Rory's out, you know, something like that. And you're...
Well, yeah. In any case, I got to say, pretty happy with the results today so far.
I am too. It's way better.
Stunning. That should be the issue.
Yeah, isn't it crazy?
Yeah.
It's absolutely crazy. Fix that just in time for Rory to leave. Yep. Jormundur says, I think that looks great. Very easy to read. Yeah, okay. Thanks for that, Jormundur. I did not see you out there. Exit fanfares, really cool. If I had like more time, I would do those like crazy, Surly. You know I would, right? It'd be like, you know, you could say bye or see ya or something like that, and it would see you saying that, and it would be like, Surly's leaving. Let's hope it's real this time. You know, something like that. I don't know. All right, Rory, thanks so much, buddy. I appreciate your assistance and help all the way through.
We'll catch you on Tuesday, yeah?
See you on Tuesday. That's right. For everybody else, I'll be here tomorrow. I'm going to keep going for a little bit. We're going to try and write some, do what was originally promised, which is write some Dungeons and Dragons related code. And let's take a look at that. I'm not, I've spent so much time working on, spent so much time working on solving this performance problem with the GPU that my mind's a little bit like, wait, where was I going? Yeah, pumpkins rolling backwards. That would be awesome.
Cornelia.
Let's do this. I think the best thing to do is I want to do this. I want to close this app down. I want to create a test case is what I want to do. Because I want to say we had a bug and I fixed the bug, but I didn't write a test case for the bug. And I suspect that it's going to take a while to write the test case. And that's a problem because I want to be able to write test cases quickly. So I want to, as a challenge, to write the test case, see how long it takes, then look at the code and see if there's a way that we can improve our API, our helper classes, that sort of thing. Let me turn off all the nameplates, but Fred's right there. And I'll show you the pieces for the that we wrote was for a feature which I can show you here called archery, which basically has this code right here that says, hey, if attack is range true, then we're going to change the attacking ability modifier of this roll. We're going to increment it by 2. And as a result, what happens is if you have that archery feature, if your character does, when you go to go with your longbow, instead of getting a, here, let's choose the arrow on there. Instead of getting like a +4, you get a +6 to your modifier. That's kind of what's going on there. And so I wanted to create a test case for it to make sure that we were seeing the +6 to that, the modifier there from that skill check. And so that's kind of what I want to do. So let's close this down and let's go look at our test cases. And let's add a test case because, whoops, wrong file, wrong solution. Where is that solution? It's way over here. Okay. Let's go into our D&D tests. Feature tests. So I want to create a new test in here. So I'm just going to come in here, hit the letter T. And I need a lowercase one. Looks like caps lock's on. And then it creates a test method for me. Now I'm going to say test archery. Feature mods ranged attacks by 2, something like that. So I need to get a character out here, and I think we had a player class called player helper. Is that right? There it is. And now I could get a player. I don't really want a paladin. Get player at level. That's what I want. And the class name, I think there's a class called fighter. Just plain old fighter. And I don't care what the level is. So that's line 1. Okay. Line 2, I want to say player.add feature. Do I have something like that? Let's do this. Let's look for feature. We got a get feature. How come I don't have an add feature? I'm going to do this, add feature, because I want this code to be easy to write. So I'm going to say add feature, archery. And I think before this, I want to say I need to give them a weapon is what I need to do. So I need to say player dot, it used to be called use, but now it's called something with the word weapon in it. Prepare weapon attack. And it needs a player action shortcut. Okay. I kind of want this. And then I want and I think I have to do this again. Let's see how I'm using this elsewhere. Am I actually grabbing? So this shortcut is working because the shortcut is created, I think when I come in here and I say add player start, somewhere in this space, this shortcut is created for that player. All right, so let's maybe consider putting that code in here. Like I said, I'm trying to make the code easy, but let's go back. Yeah, I'm kind of fighting it. So this is more along the lines of what happens when we run a game and create a game. Instead of add player, let's do this. And I need to add the weapon to the player. And then we're looking for a 2 right here. Now, how do I simplify this code? I think it looks like this. And then I want to take this promote to parameter. This is going to be the player class. Take this one, promote that to parameter as well. This is going to be the level. I think add weapon's not. Yeah, initial weapon. I think I am going to do this. Promote that to parameter. Initial. Maybe just weapon. We've got null. Player.add weapon. So now we have player start new game fighter level 1 with a longbow. Then we've got to prepare weapon attack. These should both be 0. Then we're going to add the feature archery. Then we're going to, I think we have to call prepare weapon attack a second time to get this to be calculated. And at that point, we're going to check to make sure that they're both equal. All right, so now let's create the things that we don't have yet, like add weapon. Let's go declare that. Thought I declared the method. Why is it not jumping in there and giving that to me? It's private. It already existed. Okay. All right, cool. So there's add weapon. Add feature. Just checking to see if that was it. All right, so there's add feature. Let's do this. You guys hear something? Whoa! Wicked Blue Ninja in the house. Afternoon, Wicked Blue Ninja. We're doing good. How are you doing? Okay. I think I just need to do this. There. So I need to come in down in here, and it's going to be not results, but it's going to be features like that. Dot add assign features from the feature name right there to and passing in this the player. I think that's all I need to do. So I think that's add feature. Okay, cool. Let's go back, and we lost our music. Is that right? Okay, prepare weapon attack. Let's declare the method. All right. We're going to do this. And so here we need to add the weapon. If it doesn't exist, maybe create it. We're looking for the player action shortcut associated with the weapon, I think. What are we using in here? The attacking ability modifier, attacking type, carried weapon. All right. From weapon. It's looking for a carried weapon. Okay, let's see if we can find it. We have carried weapons in here, I think, don't we? We get the readied weapon. We have a list. There they are, carried weapons. So I want to check to see if it's in that list. All right, so we're going to say found weapon there. If it's equal to null, then I guess we got to add it. Let's go see how we're adding these already. There it is. Add weapon. All right, cool. So we're just going to call it add weapon right there. Do we already have another add weapon? What did I name the piece that I'm in already? Oh, it's prepare weapon attack. Okay, so then we're going to come here and say add weapon, weapon name, like that. And then we're going to, I think, repeat this line of code. Unless add weapon returns it. It does not. I'm going to change it so it returns it. Turn the carried weapon. We're going to hit the coder's key right here and choose convert to function. That's going to then return carried weapon right there. Good. So now we can come back down in this code and we can say, hey, the found weapon is equal to add weapon. Much simpler. We don't have to make that call again. So now we are good. Should be good to go. Although there's still a chance for it being null. So I'm going to be like, hey, if that's null, then we're going to get out of there. And now we can call from weapon passing in the carried weapon. Item effect is going to be null. And the player is going to be this. And that's going to get us our player action shortcut. And then we're going to call prepare weapon attack, passing in that shortcut. And that might work. Is that right? Oh, no, wait, hold on. But this gets me a list of them. Yeah, okay. It gets me a list because some weapons have multiple attacks on it. I'm going to pass the first one in. It's a test method. It's going to use the very first one. So the longbow, it's going to be okay. The let's see if this maintains any list of shortcuts. We do have a shortcut. Oh, wait, not quite. All action shortcuts get from player ID shortcut name. Why do we need the player ID for the action shortcuts? Okay. Because the shortcuts are associated with the player. And I think those are built around the time we start the game. I think this code will still work. I think I'm going to call this test prepare weapon attack to indicate that it's only called from test methods. I don't know. I think there's a chance it'll work. Should we try it? Let's debug the test. Set a breakpoint. Start new game. Do we have a problem in there? Nope, we're okay. All right, game start. Nope. There are features created here. If we're bringing it over from a character DTO, then maybe all of this code I'm adding is not great code. I'm starting to think it was totally I'm doing the wrong thing. That's what I should have done. Now we can get rid of all those null refs. Better. All right, let's all right, run it one more time. Here it goes. It passed. I just ran it without debugging it. Holy cow. All right. Well, that's not bad. So the question is, how easy or simple, how easy or hard is this to test? What's 20th of Myrtle? Date of something? Yeah, it's today's date in Dungeons and Dragons time is what it is. That's our Dungeons and Dragons clock there. And so that's basically just doing a conversion from our date to theirs. They have 12 months with 30 days each. They have 4 holidays, I think, and every leap year they have a 5th holiday. Something along those lines. So they have these holidays between the months, seasonal holidays. So that's what's going on there. That's just our Dungeons and Dragons clock. I'm just looking at this from the standpoint of how hard is it to write this test case? And I guess, should I be thinking it should be any easier than this or not? That's kind of what I'm looking at. So to do this, I start a new game, I pass in, I say I want a fighter at level 1 who's got a longbow. I call test prepare weapon attack with the longbow. That gives it, that builds up the pieces the character needs. The game is started. I check to see is the attacking ability modifier bonuses roll 0, and it should be. And then I add the feature. I call test prepare weapon attack one more time, and then I check to see if the attacking ability modifier bonuses roll is now a 2 because of the archery component. So yeah, I guess it's okay. It's just like I'm trying to visualize these a little bit more, try to figure those out in my head, what I want them to look like. I think I want to call that a show. That's what I think I want to do. I think I need a little bit of time to kind of think about what I want to do next on here, because I'm not entirely sure what that's going to be. Let's go see who else is streaming out there. And today we did kind of 2 cool things. One of the things we did is we redesigned our name tags so they suck up less GPU, which I'm happy about it. All right, you showered? Cool. Let's see who we're following out there right now. C# Fritz. Here we go. We'll send you over to Jeff. Welcome. Thanks, kids. And we'll see you tomorrow. Be back tomorrow about the same time.